So we all knows that in yesterday's class we discussed what is buoyancy force and what is the cause of buoyancy. So simple meaning, if I want to say you buoyancy, so what is the meaning of buoyancy? Anybody? The force exerted by what? All of you? Buoyancy.
Upthrust.
Yes. So buoyancy means the force exerted by a fluid when any object is immersed in it. So if I take any kind of a liquid or fluid, whatever it is, so if any object is immersed in it, what kind of immersion? Either partially immersed or completely immersed.
Completely.
Suppose some objects may be partially immersed, some objects may be completely immersed, some objects is completely going to sink. Of course, that is the secondary. So, buoyancy is whenever any kind of object is immersed in the fluid, then the fluid will try to push that object in an upward direction. The force which is exerted by the fluid in the upward direction is only we used to call it as buoyancy, or we can use to say buoyant force, or it is exerting normal to the surface from the downward direction. So that is
Upthrust.
why it is we used to call it as, what we used to call all of you? We used to call it as a upthrust. So we all know thrust. What do you mean by thrust, Rasini? Thrust means the force which is exerting normal to the surface, perpendicularly or normal to the surface. That is what we used to call it as a thrust. Now, if the same thrust, if it is acting upward direction, means from the bottom it is exerting, it is acting upward. So we used to say up thrust. That's all. This up thrust exerted by the fluids when any object is immersed in it, only they will experience it. So that is called it as a buoyancy or buoyant force. Now, yesterday we studied the cause of buoyancy. So what is the cause of buoyant force, everybody? So the force experienced by the upper surface and lower surface of the body is not same. That is only the cause of buoyancy. So we all knows that. So what will happen, everybody? If I take a container where it is fully filled with the water, so we all knows, let me take any kind of object which is completely immersed. When an object experience more maximum buoyancy force, anybody? When an object will experience maximum buoyancy force, partially immersed or completely immersed? Everyone?
Completely immersed.
Completely immersed. Remember, maximum buoyancy force experienced by an object is when the object is completely immersed. So, if I take any kind of beaker, for example, only now half of the object is immersed. Now the same object will sink completely. It will go inside the water. Then here it will experience the greater buoyancy force compared to here. Agalya, do you understand what I'm saying? Everybody? All of you? So if the object is partially immersed also, it will experience the buoyancy force. But if it is completely immersed, it will experience maximum buoyant force when the object is completely immersed. Now, let me take an object which is completely immersed. I am taking one cube or a square, what is completely immersed. Now, it is having a two surfaces. What is the two surfaces, everybody? This is upper face and this is what? Everyone? Lower face. Okay. So now, compared to the upper face, from the top, you can check it. The upper face is only at this height and the lower face is only, lower face is on this side. Now, which surface will experience the greater force, greater pressure, everybody? Upper surface or lower force? Lower force. That is what. So that is why the pressure difference in the upper face and the lower face is different, because upper face and lower face are at different depth. So different depth means, so where it is more deeper, it will experience the more pressure. So which surface of this object will experience greater pressure? Everybody? Yes, please. Lower face. So lower face, the pressure is more than the pressure at upper face. So the weight of the object will always act downward direction. That is what, let me take downward force. So downward force I'm taking as a F1. Then the liquid will exert, they will push the object in the upward direction. That is what we used to take it as a upward force, which is F2. Now, this upward force is greater or lesser or equals to object. That is what you always need to calculate. Net force is equals to F2 minus F1. That is what downward force minus upward force. So, sorry, upward force minus downward force. So, what is the use of it? Today we are going to study. So, what is the use of it? Sanjay also having the same doubt. So, how you can use this one? So, remember, the net force on the body is always in upward direction. That is what the buoyant force, which reduces the weight of the object. That is why whenever you are inside the water, you will feel your body weight is lighter or you are heavier. Everybody? Yes, please. Yesterday also I have taught you. You'll feel what? Whenever you are inside the water, you'll feel lighter or heavier. You'll feel lighter because of what force? So because of the liquid is pushing you upward direction. So that force only we used to call it as a what force? Everybody, please respond. Buoyant force. So that is why it is easy to carry the objects even in the water, or it is easy to you will experience more lesser weight of your body when you are inside the water or any liquid. That is what. Now, if you notice it, what about the sides at the horizontal surfaces, left and right side? What will happen, guys? Everybody, pressure is what? Same or different? Remains? Yes, please. Remains same, because according to Pascal's law, at a given depth, the pressure is distributed uniformly. So pressure is distributed uniformly in all the directions. So that is why both the sides pressure is equal and opposite. So it will be cancelled out. So the effect of pressure in the horizontal phase is, any effect is there? No effect of pressure. No effect of pressure on object in horizontal level, because horizontal surfaces there is no effect of pressure because both are equal and opposite in every given depth. That is why they will never show any effect on the object, only upward surface, upper face and lower face alone. So that is the cause of buoyancy. So now, as I said yesterday, what is the use of this F net? Let us see that now. So for example, if I take, all of you observe this picture carefully. Now in this totally you see the 4 cylinders. Now all of you observe very carefully. The weight of the object. What is the object I have dropped here? Everybody see here. What is the object I have dropped here? Everybody? Sorry. 1 minute. Yeah. What is the object I have dropped here? Anyone? Yes?
Cork.
So cork is now floating. See that the immersed portion is less or more? Everybody? The immersed portion is less or more?
Less.
Everyone? Less. So it is experiencing more buoyancy force or less buoyancy force?
Less buoyancy
More
force.
More buoyancy force. Understand, Mari? The more it is floating, the more higher the buoyancy force. Purima? Do you understand, everybody?
Sir, but you yesterday have said that
Yes.
when it is immersed completely, it will.
That's what. No, it is
change.
big. When it will sink completely, it will experience the greater buoyancy force. But that is not I'm saying. Now, who is the dominating one? Here you can see the dominating force is buoyant force. Weight of the object is acting downwards. Do you understand, Mari? Weight of the object is acting downwards. Buoyancy force is force of buoyancy, FB. Please FB write. So if FB is greater than weight of the object, then the immersed portion of the object is very, very less. I am not talking about that. Do you understand what I am saying now?
Yes, sir.
That is clear. So the difference between the buoyant force and weight is very, very high. Then the immersed portion is very less. So it is what? positively buoyant or negatively buoyant? Verify it. So if you get F net, so F net is equals to downward force. That is what? F2 minus F1. So that you will get a positive result or negative result, guys. Everybody.
Positive.
Positive. Next, instead of cork, I put wood. Now see, I set. What is the immersed portion, everybody? If I put wood, immersed portion is more than a cork. More than a half it is immersed. Am I right or wrong, everybody?
Yes, sir.
Yes. Means what? The buoyancy force is still it is greater than weight of the object, but there is no much differences. That is why immersed portion is little higher. Clear, everyone? So now also you can see if I take the F net is equals to what will happen? F2 minus F1. Positive or negative? Everybody. You'll get respond positively buoyant only. Clear, everyone? Next, object is sink. I have taken a aluminium. Now you can see it is experiencing the maximum buoyancy force, but still the weight of the object is greater than buoyant force. That is why the object is sink inside the water, so or liquid. So we can get F net, negative or positive? F2 minus F1, we will get negative. That is why it is sinking. So we'll get negative buoyant. Means buoyancy force is less or more? Buoyancy force is less than weight. That is what? Negatively buoyant. Understand? Agalya, Shivani? That is what you have to remember it. Okay. Next, here you can see it went more deeper. More deeper it sinks. More deeper it sinks. So means in the sense of the weight of the object is more greater or less greater? Everybody. The weight of the object is more and more higher than the buoyancy force. So it will leads to negatively buoyant. So F net is equals to F2 minus F1. So the difference is negative. Sanjay, understand, Sanjay? What is the importance
So
of
one doubt, sir.
Yes.
Sir, when an object is completely immersed,
Yeah.
then its external force will be greater, sir.
Yeah, if it is external force is greater, the weight of the object is greater than the buoyancy force, then the object will sink.
Yes, sir.
Understanding? But it is suppose it is now here see, it is almost like floating. Here it is see, almost it is settled down. So here it is greater weight. The weight is more than the buoyancy force. But when the object is completely immersed only, the maximum buoyancy force will exert. Are you clear?
Yes, sir.
But if the weight of the object is greater, then the object will sink. If the weight of the object is less than that buoyancy force, then the object will float. That is what you have to remember. Okay? We'll
Yes,
study
sir, the
that.
maximum amount of external force will be applied when the object is completely synced.
Yeah, external force not Mari. Weight of the object. Weight means what? Mg. Do you understand it? Mg, mass
Yes.
into if this is more than, greater than the buoyant force of a liquid, then the object will sink.
Yes, sir.
Okay?
Yes, sir.
Yeah. Do you understand, Mr. Sam, Sanjay, Kavya? This is what it is. So F net is equals to F2 minus F1. Upward force minus downward force will gives us negative buoyant or positive buoyant. We will understand it. Anybody having any doubt, you can ask me. So this is the most important thing which you need to learn, everybody. Clear, Niroshi, Arasini, Hasini, Sudhaka? Yes, please. Any doubt, anybody can ask me. So please kindly make attention. So this is what is about it. Now we are going to study the next concept is density and relative density. So relative density and density, which will be having more importance in our daily life. You all can even use it in our any kind of concept. Okay. So they're asking in which was
Can you
it?
please send that image afterwards?
Yeah, I will send. I will send. So remember, positively buoyant force when weight of the object is less than the buoyancy force, positively buoyancy. If the weight of the object is more than the buoyancy, then it is that is called as negative buoyancy. Clear, Amma? Laksha? Mr. Prithvi joined, I think, in second one.
Yes, sir.
Yeah. Prithvi, are you there? Clear, everybody? Do you understand, all of you? Now, we are going to study
Yeah.
the next concept, call it as a density. So please make it everyone. Density will represent with a D or a rho. Rho. The symbol is what we used to say? Rho. Please make it. Any doubt? Anybody can ask. Shall we start now? All of you?
Yes.
Yeah. Mr. Prithvi,
Yes,
I'll
sir.
join in first link first, second link second meeting. Okay. Gokul, understand or Gokul? What is the cause of buoyancy force? Very simple cause of buoyancy force. Upper surface and lower surface are different depth. So who will experience the greater force, greater pressure? Everybody. Bottom surface compared to the upper surface. That is only the cause of buoyancy. In horizontal, there is no effect because at the given depth, pressure is uniform. So what do you mean by density? So let us write it. Density, right, all of you. Density of a substance is defined as the mass existing for unit area, because without knowing the density and relative density you cannot understand sinking and floating concept. That's what I'm saying. So existing per unit volume, that is only called as a density. Mass per unit volume, if you want to say simply, mass per unit volume is only called it as a density. Okay. So the knowledge of density is very, very important, because if you go for future engineering or whatever it is, constructing bridges, constructing buildings, constructing ship, constructing some other XYZ, everything, if you get an idea about the mass of the material, you without knowing the density, you cannot construct any kind of object, whatever it is, because we need to know the density, because either that object will sink or float will decide based upon the density only. So that is what it is. Okay. So density is equals to formula. Density is equals to mass by volume. At least now you should learn. Maybe you have to learn at the early, but it's okay. Rho is equals to mass symbol is capital M, volume symbol is V. So this is the formula for density. Even already we used this formula. From this, mass is equals to what? Everybody. Mass is equals to density into volume. We have already used it, correct, guys? Liquid formula derivation. Am I right, Mr. Sam? Density, that is what. So please make it. Any doubt, anybody can ask me. So density. Now, what is the SI unit? This is very important. SI unit of density. Any doubt, please ask me. What is the SI unit of mass, guys? Anybody can tell? What is the SI unit of mass? Yes,
kg.
please. Yes. SI unit of mass divided by SI unit of volume. So, what is the SI unit of mass? Everybody, kilogram. What is the SI unit of volume? Agalya? SI unit of volume.
Meter cube.
Meter or minute. Very good. This is the SI unit. Then what about the CGS unit? Fastly. Gram per
Gram.
gram
Centimeter
per
cube.
cubic centimeter. That is the CGS unit of density. Mr. Gokul Raja, can you hear me? Are you doing?
Yes, sir.
Yeah, do it. Everybody. Alfin late, always. You should learn everything how to be on time. Make it everybody. So what is the density formula, everyone? Mass by volume. And what is the SI unit of density? Everybody? Yes, please. SI unit of density is kilogram per cubic meter, and CGS unit is gram per cubic centimeter. Okay. Arasni, understand Arasni? Gokul, Hasini, Sudhagar, Hasini. Any doubt? Anybody can ask. Clear? So now you can see a density is the characteristic property of a substance. I'm keep on calling you. Nobody is saying anything. So okay, that's fine. So what is see that? Is this density same for different materials? That is what is my question. Everybody? Yes, please. Is it a different different substances having same density or different density? Yes, please.
Different density.
I will give you 1 cubic meter volume of a cotton, and I will give you 1 cubic meter volume of a iron. Does it both density is same? That is what is my question. Everybody, volume is remains same volume, but do you think the mass is remains same?
No, sir.
No,
No, sir.
that is
No,
not. So, different substances has different density. So that is very important. Clear? So that is why we will say density is the characteristic property of a density is a characteristic property of a substance. Any problem for anybody, you can ask. Now, let us see, for example, I will say the density of water. Can you tell me what is the density of water? Yes, please. Density of water. Now, one more interesting thing I want to say about the water, I will say you. So basically, density of water, if I have taken, because water is the universal solvent. Universal solvent. The advantage of water is, remember, if I take 1 gram of water, how much grams of water? Everybody? How much grams of water? 1 gram of water. It will occupy 1 cubic centimeter volume. 1 cubic centimeter volume. If I take 1000 kg water, it will occupy 1 cubic meter volume. No other substance will have this facility. Do you understand? The one and only substance who will occupy 1 cubic centimeter volume or 1 gram of water. That is why the density of water is 1 gram per cubic centimeter or 1000 kilogram per, what guys? 1000 kilogram per cubic meter. Do you understand, everyone? That is the density of water. How much, everybody? Density of water? 1000 kilogram per cubic meter, or we can say 1 gram per cubic centimeter. That is what is the density of water. Now, let us see the relationship between SI and CGS unit of density. Extremely important. You all will confuse it. Let us see the relation between.
For a minute, can I please show it out?
Yeah.
Downwards. Yes, sir.
Relation between kilogram per cubic meter is equals to dash gram per cubic centimeter. Shall we study now, everybody? If you are ready, I will make it. Everybody ready? Okay. Now first, tell me what you know. So we know 1 kilogram is equals to how many grams, guys? 1 kilogram is equals to how many grams? Adi theriyada? 1000 grams. Prima, Nivedan. Next, 1 cubic meter is equals to dash cubic centimeter. Agalya, 8th class I taught. Mari, Sanjay, many people I have taught you in 8th class. 1 cubic meter is equals to dash cubic centimeter. This is all there for you. You have to learn. Idi theriyada? No use. Yes. Answer, please.
Yes.
Everybody, it's very simple. Area I have taught you. Same way you can take it here. So it is very easy also.
10
Yeah,
power 6.
10 power 6. Sanjay, very good, Sanjay. So 10 power 6 cubic, 10 power 6 cubic centimeter. This one I will write 10 power 3 grams. So how it will become? See that, everybody. 2 cube means I will write as a 2 into 2 into 2. Same way, I will write 1 cubic meter means what I can write, guys? Speak loudly. 1 meter into 1 meter into 1 meter. Purima. So volume is a 3-dimensional one. Volume is a 3-dimensional. So 1 meter means how many centimeter? Everybody? 1 meter means how many centimeter? 100 centimeter. For those who are, if I call your name, if you are not responding, you can leave from the meeting. No issues. Again, 1 meter means again 100 centimeter. So 100 into 100 into 100, you can see 10 lakh. Centimeter into centimeter into centimeter, cubic centimeter. So 10 lakh I can write as a 10 power 6 cubic centimeter, which is equals to 1 cubic meter. Any problem for anybody? You can ask. Are you clear, everybody? Yes.
Yes, sir.
That,
Yes, sir.
no, you can substitute it here. Shivani, you can able to understand. So now you can substitute it.
Yes, sir.
1 kilogram per cubic meter. 1 kilogram means how many grams, guys? Everybody, 1000 grams divided by 1 cubic meter means 10 lakh. 10 lakh cubic centimeter. So what will happen, everyone? You all should respond. 10 power 0, 10 power 3. See that. 3 with 3 will 0, 3 will get cancelled. Which is equals to what is remaining? 1 by 1000. 1 by 1000 gram per cubic centimeter. Purima. So which is equals to 1 kilogram per cubic meter is equals to 1 by 1000 gram per cubic centimeter. That is the relation. Now, 1 by 1000 will come this side. What will become, guys? Anybody can tell? 1000 will come this side. It is in division. Will come this side. What will become? Everybody.
Multiplication.
Multiplication. So, 1 gram per cubic centimeter is equals to 1000 kg per cubic meter. That is the relation, the most important relation about the density. You all should learn. 1000 means I can write 10 power 3. So 10 power 3 cubic meter, sorry, 10 power 3 kilogram per cubic meter is equals to 1 gram per cubic centimeter. This relation is equals to something, density of water. Have you checked it, everybody? Density of water, yes or no? Have you all remember, everyone? Density of water also same. Correct or not? Check it, everyone. Density of water 1 gram per cubic meter. 1 gram per cubic centimeter, which is equals to what? 1000 kilogram per cubic meter. Both are same or not? Verify, everyone.
Yes,
Yes,
sir.
sir.
That is. So basically, water is the only substance who is having this. That is the reason we will take always, we will compare any substance with the water. That is what you have to remember. Okay. Any doubt, anybody can ask. Clear, guys? Laksha, it is.
Sir, one doubt, sir.
Yeah.
Then we can say a standard formula for this, no, sir.
It
Like
is
1 kg.
1 kg per cubic meter is equals to reverse. 1 kilogram per cubic meter is equals to 10 power minus 3 gram per cubic centimeter. Purima?
Can we make it as a standard formula?
Yeah, this is what, this both you should learn.
Yes,
Both
sir.
are very important.
Yes, sir.
Both are extremely important. Purima, everybody? Yes? Any doubt, anybody can ask. Mr. Prithvi, clear? Sam?
Yes, sir.
Yeah. Make it quick. Agalya, any doubt, Agalya?
No, sir.
Kavya? See, unit conversion, if you don't know, you cannot ask your sisters, those who are studying 11th, 12th and all. If you don't know the unit conversion, it is impossible to study the physics, 11th physics and 12th physics. That much importance. You must have an idea. Mr. Mukesh, anything doubt, ask me, Mr. Mukesh. Or else solve. Everybody has to solve. Vairam Sahasini, are you solved?
Yes, sir.
Gokul Raja,
Sir.
completed.
Yes, sir.
Alfin, understood anything doubt, ask me, Alfin.
Yes, sir.
I'll ask again, later in not solving, I'll say you. Everybody same. So we'll proceed now. This is what is the relation between density and density, SI and CGS unit. Next. This is the first time you are going to study this concept. You never studied before. That is what is the concept, call it as a relative density. So this is the extremely important concept for mainly the concept of sinking and floating concept. So whatever it is, doesn't matter. So let us see, what do you mean by relative density means? This is the easiest concept which will help us to identify the density of any substance, density of any liquid in this world. Okay. So what do you mean by relative density? Means, observe very carefully. It is the ratio of density of any substance to the density of water. Means if you compare the density of any substance with the density of water, that is only call it as a relative density. So relative density will give you the information. The density of a given substance is how many times more than the density of water or how many times less than the density of water. So it is a ratio of density of a substance to the density of water. That is only call it as a relative density. We are having many applications of this. You will study while sinking and floating concept. So relative density is equals to, all of you observe, what is that? Density of a substance. Density of a substance divided by density of water. Density of water. Again, I will use a word, call it as at 4 degrees Celsius. So now, once again, I'm saying you, this is only call it as a relative density. Ratio of density of a substance to the density of water at what temperature? Wait, Mari, I know your question. At what temperature? 4 degrees Celsius. Sir, why, sir, only 4 degrees Celsius I'm saying? What is the density of water I said? Anybody? Density of water, just I said you. What is the density of water? Just now I said up. Density of water. What such a very worst actually it is. 1 gram per cubic centimeter or 1000 kilogram per cubic meter. So remember, this is the maximum density of water. Maximum density of water. Only it will show at 4 degrees Celsius. If the temperature is less than 4 degrees, again density is decreases. Density decreases. Only for water this character, no other substance. And temperature is greater than 4 degrees. Also density decreases. That is the problem of the water. Water is having only maximum density at what temperature? Everybody? 4 degrees Celsius. No other substance have this facility. Only at water, for water is having a maximum density at 4 degrees Celsius. And above that also density is less. Below that also density is less. That is why ice will float in water or sink in water. Anybody?
Float in water.
Float in water. Do you understand it? Because density of ice is less than the liquid water. So keep it in mind, all of you. For example, I will give you water at 1 degree Celsius, water at 4 degrees Celsius. Who is having a greater density? Anybody tell?
4 degrees Celsius. 4 degrees
Yes,
Celsius.
4 degrees Celsius. Water at 4 degrees Celsius and water at 10 degrees Celsius. Now, where it is maximum density? Everybody? 4 degrees Celsius. Less than that also decreases, more than that also decreases. This is the only possible for water. This is a character, call it as a anomalous behavior of water. Anomalous behavior of water. No other liquid substance, no other fluid is having this facility. That is what you have to remember. Any doubt? Anybody can ask. You understand, everyone?
So what is spelling for it?
Anomalous behavior. ANOMOLOUS. Anomalous behavior. Clear? Everyone? Please respond. All of you? Yes. So you take it, that is what? So what is relative density? Comparison of any substance density with the density of water, then that is called as relative density. So both density units will get cancelled. What is the units of relative density? Anybody? Units of relative density. Everyone? No units. Clear? Because density units is what? Kilogram per cubic meter. Another unit of density is what? Kilogram per cubic meter. So kilogram per both will get cancelled. What is the units? Everybody? Relative density. Yes, please. No units. It is unitless quantity. That is what you have to remember. And a device which is used to measure the relative density is called it as hydrometer. For general awareness, it is very important. A device which is used to measure the relative density is a hydrometer. Relative density of what? Relative density of RD, relative density of liquids. So hydrometer. Clear, everyone? All of you? Understand, Amma? Everybody? So relative density. Now, sir, what is the use? As I said, observe very carefully. Now, I have given you some XYZ object. Understanding? X object, some Y object, and some Z object. Now, these objects will sink or float. How we can say? Where? Water. So, I have given you one bucket of water. So, either I can say either the object will float above the surface of water, or they will float inside the liquid, or they are going to sink. They are going to settle down. This is floating inside the liquid. This is floating above the water, surface of water. This is sinking. So relative density RD is actually 3. RD is less than 1. RD is greater than 1. RD is equals to 1. So keep it in mind. RD, relative density is less than 1. Float above the surface. Clear, everybody? Above the surface of water. Next, RD is greater than 1, object will sink. RD is equals to 1, float inside the liquid. That is the importance of inside the water. That is the importance of relative density. Do you understand, Amari? Mr. Mukesh, Kishore, everyone?
Sir.
All of
In
you?
values, how can we find it, sir? Because it
That
will
we
be
will
in
give you.
ratio form.
They will give you. They will give you. For example, let me take that. Density of iron. Density of iron is 7.8 gram per cubic centimeter. Clear? What is the density of water? Density of water, how much? 1 gram per cubic centimeter. Now, relative density of iron, if you notice it, what is that? Density of iron divided by density of water, which is equals to 7.8 divided by 1. Units will get cancelled. My meeting is going to end. Again, you join. I will send the meeting link. Already sent, I think. So, unit will get cancelled. So, what is that? RD. RD value how much, guys? RD of iron? 7.8. 7.8 is